Okay, let us now take a look on the program code. And firstly, I would like to concentrate on this test case. What we have here. Here we have just a simple call of find all method of this repository. Let us take a look on this repository. It's eager user repository. Here we can see that find all method is not redefined. It means that in our test case, we are going to call original find all method, which is generated by Spring framework. And if we take a look on our entity, we can see that our relation ship one-to-many with posts has a fetch type eager. And let us run this test case and take a look after that on logs. And we would see that how many queries Hibernate produces for this type of, let's say, entities implementation. Running this piece of code requires some time because I'm using test containers as a platform for testing integration with database. And here we can see in our logs that we have exactly 4 SQL queries. Why 4? First, SQL queries is devoted to retrieving data from user tables. And another 3 queries are devoted to retrieving data from post queries. And why we have 3 additional queries? Because, as I said previously, we have 3 users in our tables, in our table users. And Hibernate produces exactly 1 additional query per user to retrieve connected posts. As we can see here, eager fetching is not a solution for N+1 problem. It's sometimes we can read some very strange information about technologies. Each time we have to prove it on a real life examples. Okay, now we have covered case with eager fetching. Now it's a turn to cover case with lazy fetching. As we already discussed, lazy fetching, the specific is that the connected data, in our case it's a post, this connected posts, they are being retrieved only when they are really touched in the code. And here we have a separate test case for lazy fetching. If we take a look here, we firstly we retrieving data, we retrieving users, and up to this row, Hibernate would produce only one SQL query. Let us take a look on the entity. If we take a look on the lazy user, we can see here that one-to-many relationship is not marked with any fetch type. By default, for one-to-many in Hibernate and also in GPA, one-to-many is lazy by default. That's why posts will be retrieved by Hibernate only when we touch them precisely in the code. And let me run this test case in the debug mode and let us check logs before this stop point and after the stop point. Okay, up to this stop point, we can see in the log that Hibernate produces exactly 1 query to retrieve data from user's table. Okay, in this row, we are calling method get of list, which returns some user, and for this user we call method get posts. And when we call this method get post, Hibernate would produce additional SQL query. Now we have only one SQL query. When we do this one, we have not. Okay, here. Okay. And now if we check our logs, we can see that we have additional SQL query with which Hibernate produces for us to retrieve to make it's possible to read posts in our Java code. What does it mean in common? It means that lazy fetching doesn't solve a N+1 problem. It's just depends on our business logic. Probably amount of generated SQL query will be less than for eager, but lazy fetching is not a solution for N+1 problem. Okay, now it's time to touch another aspect of N+1 problem. It's connection between batch fetching and N+1 problem. Again, in some articles in the internet, we can find information that batch fetching is a solution to solve and avoid N+1 problem when we are using Hibernate. The statement is true, but partially true. Batch fetching, it's really reducing the number of database queries. It's true. And I'm going to show to you how the number of queries is being reduced. But in general, we cannot say that batch fetching results one query. Yeah. We have solved N+1 problem only if we receive exactly one request on different size for the same data scheme. That's why I am calling batch fetching workaround, not a solution. That's why it's another aspect, and in some articles you can find information that batch fetching is a solution for N+1 problem. No, and let's take a look why it's a workaround. Okay, now it's the time to take a look on another test case for batch size. What we have here? Here we again have batch user repository and retrieve all users in our database. Just as a reminder, in our database we have 3 users. Here we have another mapping of table users to Java class, it's batch user. Here we have our relationship, one-to-many with post, and the fetch type is eager. And here we have another annotation batch size, and size of batch is set up to 3. Let us run this test case and see how many SQL queries Hibernate would produce in this case, and what is the type of this query, how these SQL queries look like. It again requires some time. And what we have here, we have two SQL queries which Hibernate produces for us. First query, it's retrieving data from users, and second query, it's retrieving data from posts. And please please pay your attention here that we have for user ID, we have not, we doesn't have here operator equal to, we have operator any. It means that here we have several values. Then it's some sort of user ID in value 1, value 2, value 3. Why I'm calling batch size a workaround? Because we don't have one query for retrieving our data. I mean data users and related posts. We have two queries. But as a reminder, I set up batch size to 3. I can change this value, for example, to 2. And let us again run it and take a look on logs and see how many SQL queries we have in this case. Okay, now in our case we have 3 SQL queries, one for users, to retrieve users, one for posts. But here we have, under operator any, we have 2 values for user ID, and for third user ID, we have the third SQL queries. Yeah, we can set up batch size equal to 1000, equal to 2000, but also for any operator, there is also some limitation. It's first point. Another point is that 1000, I mean, we cannot hard code this value 1000, 2000, just to, to guess how many uh, rows we should retrieve in one batch to minimize queries. Our data can be grow in amount, and that's why today we have 1000, tomorrow we have 2000. That's why this batch size, it's a workaround. It's not a solution.